All right, hey everyone, we're HyperWatch and we're focused on tracking maneuverable hypersonic missiles. And unlike most other teams, we actually brought our own problem statement to our sponsor, and we decided to tackle hypersonic defense because we thought it was the biggest and most important threat the US currently face. And so we started on the right with a pretty broad problem statement, basically saying we need to stop hypersonic threats. And since then, we've done 107 interviews and narrowed our focus to improving defense of regional defense of critical land-based assets against theater-range hypersonic threats by providing more fire quality control tracking data. Okay, so here's the team. I'm Brian. I'm a master's student in aeroastro.
I'm Adam, also master's student in aeroastro.
I'm Alexander, also a student in aeroastro.
I'm Sydney, a junior studying mechanical engineering.
And I'm Cooney, a student, NSX student at GSP.
Okay, and now we're going to show a 2-minute video giving some background on the problem and what we've been working on.
On May 20th, 2025, President Trump announced the Golden Dome Missile Defense Shield.
Once fully constructed, the Golden Dome will be capable of intercepting missiles, even if they are launched from other sides of the world, and even if they are launched from space, including hypersonic missiles, ballistic missiles, and advanced cruise missiles. All of them will be knocked out of the air.
Boosted hypersonic glide weapon, which is an intercontinental missile that can maneuver and evade defenses. These missiles are launched into space and ultimately travel at extremely fast speeds, greater than Mach 5. And after they enter the atmosphere, they maneuver to their targets on a glide vehicle. Because they can glide at low altitudes and change course midair, they can be extremely hard to detect and counter.
And this is China's first known model. The relative newcomer to the technology unveiled the weapon in 2019. This type of missile is regarded as one of the most advanced military tools in existence and a hard to detect weapon that current defense systems struggle to take down.
Establishing a layered domain awareness network to detect and track threats approaching North America from seabed to space remains our top priority, because you can't defeat what you can't see.
HyperWatch. We give the U.S. Army double the time to react to hypersonic missiles, at 1% the cost of today's solutions. The problem with current sensing solutions is that hypersonic weapons underfly ground-based radar, which makes them invisible until too close to the target. Tracking from orbit is a high-speed, sub-pixel problem, making it difficult to deliver fire control quality data, which is data with enough precision for successful interceptor engagement. HyperWatch is building a network of stratospheric balloons which fly above terrain and horizon limits, keeping persistent tracking of low-altitude threats. These systems can be fielded rapidly and for a fraction of the cost of existing systems, shortening time to mission readiness. Sensing at a 50th of the altitude while station keeping reduces handover error and provides fire control quality data. HyperWatch, tracking the untrackable.
Okay, so that's where we are now, but it has been a very long road to get there. We interviewed, as our Professor Steve Blank can tell you, but yeah, we interviewed 107 people over the past 10 weeks, and we're going to use this presentation to walk you through the journey we went on and how we got where we are now. And so we think it's best described as an emotional journey because our team has been through a lot of highs and lows over the past 10 weeks, and we'll walk you through each chapter of that journey.
Good evening. It is my pleasure to tell you the story of how incredibly naive we were when we started a few weeks ago. And you can tell because we're still happy at this point. So we entered the course knowing that hypersonics are a big issue, but what about them? Just saying that they're dangerous is too broad of a problem statement. And so we spent the first few weeks finding the piece of the puzzle that we could contribute the most to. And we identified these three: generating synthetic data to train machine learning algorithms, data fusion techniques, and thirdly, airborne sensing platforms. Well, the first one was quickly eliminated because through our interview, we discovered that the DoD already has this data because they already conducted flight tests. And so we went into the following weeks with these two options in our minds.
And it was around weeks 2 or 3 when we really started to realize how massive the problem we had picked was. And so we were trying to answer the question, who owns the hypersonics problem? And the first thing we realized is this is not just a Space Force problem. Space Force is one component of a much broader missile defense architecture. And as an example, airborne sensing is something that would not be owned by the Space Force. And so in week 3, we made this diagram, which is basically an overview of the parties involved in missile defense. And we were actually able to answer the question of who owns the hypersonics problem. And the answer is everyone. And we felt pretty overwhelmed at that point because we realized literally everyone in the DoD is working in this, and we somehow have to figure out who our specific beneficiary is going to be. And so previously, we thought that was going to be Mission Delta 4 within the Space Force, and we identified new potential beneficiaries as the Combined Space Operations Center within Spacecom, if we worked on the data fusion problem, or the Army and Navy interceptor operators if we worked on the airborne sensing problem. And so from that, we were able to generate 3 distinct sub-problems, each with their own beneficiary. The first was improving global space-based tracking with better data fusion for the Space Force. The second was improving regional defense of sea-based assets for the Navy with airborne sensing. And the third was improving regional defense of land-based assets for the Army.
At this point in weeks 4 and 5, we were feeling quite low. We still didn't know who our beneficiary was, and we were starting to realize how complicated this problem actually is. But in a few key interviews during these weeks, we started to gain our stride back. So in these interviews, we learned that regional defense was an area we could have the biggest impact due to the importance of theater defense and the ability to use airborne sensors as a backup to satellites and add resiliency to the overall missile defense architecture, and it directly addressed our adversaries' weapons. So this allowed us to eliminate global missile defense and fusion and really focus on regional defense of sea-based and land-based assets. Our first MVP was a balloon tethered to a Navy cruiser or destroyer. With it being tethered, it meant that it would be easier to station keep and potentially easier to integrate. However, using a radar meant extreme power constraints. And with it being tethered to a ship, it meant that the balloon's location was constrained to the ship's location. And this MVP, designed for protecting land-based assets, this is an untethered balloon with an IR sensor. Having an infrared sensor means lower size, weight, and power requirements. And with it being untethered means you can deploy it over any land-based asset. However, it would be more technically and logistically challenging to operate. In interviews and through additional independent research, we realized that regional defense of land-based assets like Guam is a top priority for the DoD. So this allowed us to really narrow down and focus on regional defense of land-based assets due to its impact and technological feasibility.
All right, so now that you have identified and confirmed a very clear beneficiary, we were feeling much more confident, and so we went ahead and confirmed our value proposition across the next few weeks. So here's a look at our MVP, which kind of highlights the idea that we've been talking about. We will deploy a network of high-altitude controllable balloons over a key area to defend, for example, Guam. And then those balloons would have IR sensors and other sensors to passively detect and track AGVs within the region. And of course, we integrate with the command and control to pass by the tracking data to Army interceptor operators. So this slide shows how we extend the defense capabilities by augmenting the total tracking time for HDVs. So here we simulated the HDV, which is launched by China to Guam, and we show that our system is able to augment by 2.6 times the total tracking time. So of course, next step was to validate this value proposition across thousands of interviews. So first of all, we were able to validate that indeed fire quality control tracking data time is indeed the key metric through the Army defense for space and missile. Also, we're able to confirm that regional defense is key for regional assets such as Guam. Actually, Guam is the first line of defense in the Pacific, and we had direct confirmation from their leadership that of the urgency of needing to have a defense against H4Ds. Finally, we also talked about the benefits of and the capabilities of sending balloons in the Pacific region with the former commander of the Pacific Air Force. And finally, and most importantly, we had an actual architect of the Golden Dome validate our idea. He was he fell in love with our idea, and he confirmed that the US is really lagging behind in strategic defense. And he really emphasized the need of having a rapidly deployable resilient layer to space satellites.
So at this moment, we started to feel even better because after we verified our value proposition. But even the best idea needs a strategy and pathways to to be brought to the users. So we started looking into the acquisition pathways over the next 2 weeks. We have identified 4 possible partners that got interested in our solutions. The first one is the Defense Innovation Unit, and we're happy to announce that we got into the summer fellowship program and open something we're working with them over the summer. The next 2 are AFWERX Open Topic and MBA white paper solicitations. And we've talked to both of the agencies, and they invited us to submit proposals for their solicitations. And the last one is Vault. This is a company in the East Coast that builds hypersonic projectiles, and they were very much interested in our balloon solution to obtain some test information for their flight tests. And now we're at the end of the class at the crossroads. Our technology readiness level is, we believe it's at 2, and investment readiness level at 3. So over the summer, we intend to improve these readiness levels. On top of that, we will continue building relationships with the DoD community and apply contracts. Thank you very much for your attention.